So let's just see what we have so far. Features of different estuary types. Positive estuaries, different types are written on the left, in the left column. We have salt wedge, called W. We have highly stratified, called H. Slightly stratified, called S. Vertically mixed, called M. We can allocate R over V ratios. Okay, if you don't know what that is, you have to watch some of the previously. Okay, the R over V ratio decreases as you move down. So you have the largest value for salt wedge, and then the R over V ratio decreases as you go down. Okay? You can also look at the salinity stratification. Now you compare the vertical stratification with the salinity of the ocean. You look at the transition zone indeed. If you only go into the river water, it doesn't make sense. Look at the transition zone. For the salt wedge, you get very strong salinity stratification. And then as you move down this list, the salinity stratification becomes very weak for vertically mixed. It's absent, essentially. So now flow magnification does something else. Okay? Because you have only little flow magnification for salt wedge estuaries, and you have only little for vertically mixed, where the exchange is essentially blocked. Okay? You get a significant exchange with the ambient ocean for highly stratified. This stands out. Here is the significant. I switch on the pointer. Here's the pointer. Significant. A big increase in the outflow and the inflow that comes in the lower layer. This is the significant link. Okay? And let's have a look how a diagram looks like. Okay, this is the diagram that you can use to classify your estuary or to understand what type of estuary do you have. This is for one estuary. Okay, or you can compare different estuaries if you want. So there are two features shown here, two properties. On the x-axis, it shows you this ratio US over UF. This is the flow magnification factor. It's a comparison of these two speeds. On the y-axis, it shows you the degree of salinity stratification from high for a salt wedge to low for a vertically mixed. Okay? And you can see that the maximum flow magnification is what you get for a highly stratified estuary. Here we are. Okay? And then you can use this diagram in two ways. You can use it actually for so-called transient or intermittent estuaries. And I show you that example. So on the next, here we go back to the Vella estuary. And have a look at the previous slides. I discussed that before. There was a big rainfall event, and then followed by a transition from a salt wedge, highly stratified, to a slightly stratified system. Again, this is shown here in this diagram. And in brackets, you can actually see the amount of river discharge into the estuary in cubic meters per second. Okay, you can see the biggest at the beginning, and then you get clearly reduced numbers here. Again, you can see there's a transition from a salt wedge, highly stratified, to a slightly stratified system. And also the flow, there's still, to the end, is relatively high flow magnification. Okay? It's the factor of more than 5 is the ratio here. So it doesn't really go back to low numbers. But anyway, you get the idea that once you have a highly stratified estuary, the inflow of seawater kicks in the bottom layer. It's a very significant feature. You can also use this classification scheme to compare different estuaries. And this is shown here on the next slide. You can see a whole range of different estuaries listed here in different colors and using the same diagram, and you can show different estuaries in this diagram. And this is the Hansen and Rattray classification from 1966, 55 years ago. Okay, a long time ago, but anyway, still relevant. But rather than just using it as a classification, indeed, you could look at changes over the years, the impact of global warming. How does this look like in a diagram like this? Okay,